Hello, dear colleagues. Today we will talk about radioactivity, types of ionizing radiation, nuclear reactions. Let's begin with radioactivity. Radioactivity is a term used to describe the natural process by which some atoms spontaneously disintegrate, emitting both particles and energy as they transform into different, more stable atoms. There are two types of atoms, stable and unstable. Each unstable atom wants to become stable, and it releases energy and extra protons and neutrons. Releasing of energy is called ionizing radiation. Radioactivity is measured in terms of disintegration or decay per time. Common units of radioactivity are becquerel, curie, or rad. They are equal to decays per time, per second, better to say. Each unit is come from four different branches of atomic industry, and let's speak about one more measurement of atomic and which atomic energy uses. It's called half-time. Half-time is a time which atom takes to reduce its quantity by half. For example, it will take about 4.5 billion years for half of the atoms in a mass of uranium-238 to spontaneously disintegrate, but it takes only 69 nanoseconds for actinium-217 to do the same task. Let's move to nuclear reactions. When an unstable atom loses its energy by emitting ionizing radiation, it occurs nuclear decay. Nuclear decay is a basic type of nuclear reaction. It's a process of releasing alpha or beta or gamma particle. Alpha particle, it is a cluster of 2 neutrons and 2 protons each, which is identical to the nucleus of helium. Beta particle, it is electron or positron, and the most interesting one is gamma particle. Gamma particle is high energy photon. So high energy photons are closer to electromagnetic waves than to particle, and they have very high penetration point. To stop them, we need to put a big layer of lead. So let's move to another type of nuclear reactions. Let's speak about scattering. There are two types of scattering, elastic and inelastic. When elastic scattering occurs, there is no energy transfer between atoms. It's just a ball which bunches the wall and goes away. But when inelastic scattering occurs, the energy is transferred, and the delta or difference between kinetic energies is saved in excited liquid, and it becomes more active. So let's move to capture reactions. Both charge and neutral particles can be captured by nuclei. This is accompanied by emission of gamma rays. So, for example, uranium-238 can absorb neutron and become uranium-239. The next type of reactions is transfer reactions. The absorption of a particle accompanied by emission of one or more particles, it is a transfer reaction. For example, two helium atoms can collide and become lithium atom, which releases one proton. So let's move to other nuclear reactions: fission reaction and fusion reaction. Fission reaction is a nuclear reaction in which the nucleus of an atom splits into smaller parts, lighter nuclei. The fission process often produces free neutrons and photons. Fusion reactions occur when two or more atomic nuclei collide at a very high speed and join to form of new type of atomic nucleus. The most famous fusion reaction is thermonuclear fusion, which is collision of tritium atom and deuterium atom. It gives us helium atom at the end and one neutron. So this was my presentation for this theme. Thank you for watching.